Okay, so welcome to our first of many Wednesday online videos. In this video, we're going to go over some of the things that we talked about in the first class. And then we're going to go back, we're going to go over the 5 different types of sampling that I expect you to be responsible for on homeworks and tests. In class, we really only talked about SRS, that's the simple random sampling. We're just going to briefly introduce what we mean by each of the other ones so that we can get a little more in depth in class next time I see you. We'll also do some more examples of using that random number table. When we did this in class, we only started with pretty simple ones. We'll do some that are a little more complicated. And then I'll also go over what's going to be on the first quiz, which is on Thursday of the first week of classes. So probably tomorrow if you are watching this now. Just a couple of businessy things. Tomorrow on Thursday, we have quiz 1. That quiz is going to include a couple of things. And I'll sort of tell you what is on the quiz over the course of this video. I'll tell you the first thing that's going to be on the quiz is a couple of questions about the syllabus. So these, make sure you look through the syllabus and you have read it. I promise not to get too nitty-gritty details, but I do want you to get the bulk of what's going on and what's expected of you from the syllabus. Also next week, Monday, we don't have class on Monday. That's Labor Day, so we only have one class in class next week. And then if you are not able to log into the Pearson website, please let me know so that I can do my best to get you set up with all of that. All right. So to recap what we did last time, we really mostly just introduced some terms. So we talked about the difference between descriptive statistics and inferential statistics. The main difference between these two things is that descriptive statistics include the entire population. So they include all of the data that you could possibly have in that calculation. I gave the example of batting averages for a baseball player. Right? We're not going to randomly choose half of their at-bats and calculate their batting average from those half at-bats. We're going to take all of their at-bats and calculate their batting average based on that. So that's a descriptive statistic. Oftentimes, we don't have enough resources or it's just impractical to have all of the data, and that's when inferential statistics becomes important. So we are calculating data. So this definition says it consists of methods for drawing and measuring the reliability of conclusions about a population, but the data is based on information that is obtained from a sample of the population. So inferential statistics don't include all of the population. They don't include all of the data. That would be descriptive. They only include information that we got from averaging over a sample that is only a subset of the population. And I've been using sample and population, so just to remind you what that means. A population is everything that could possibly be included, and the sample is the subset of the population that we're choosing to do some data analysis on. If you are looking at descriptive statistics, you're doing your data analysis on the entire population. If you're doing inferential statistics, then you're only doing your analysis on this sample of the population. Okay, the next thing that we talked about was simple random sampling. So the first thing that you think of when you think about how does one collect this sample and how do we be objective about how we choose our sample is to just be as random as possible. And that's what simple random sampling is. So this is each possible sample of a given size is equally likely to be the one that is obtained. And there will be a quiz question on simple random sampling, and it will be a question that asks you to use this table. So let's pull out this table. So this is our table of random numbers. And every one of these numbers is randomly chosen to be at some point, and it's how we're going to analyze things when we're doing them in class, to randomly pick a group of things. So here's an example of what I mean by that. So I'd like to select a sample size of 4 from a population of 60 people. So this is like I have a class and there's 60 people in the class. I don't want to interview all 60 people, but I do have enough time to check in with 4 of them. So I'm going to randomly choose 4 people from my class and interview them to get some ideas about things that are working. In order to choose those 4 with SRS, with simple random sampling, I'm going to use a random number table. And I have to first pick where I'm going to start on my random number table. So the first thing I'm going to do is let's just start at line 0, 0, column 0, 0, and I'll read from left to right and top to bottom. So let's do that. I have a population of 60 people, so I need to read off 2 digits at a time. And let's do that. So I went ahead and wrote this out on a different piece of paper. So my first example that I'm trying to do is this one, right? I'm starting out line 0, 0, 0, 0, and I want to read left to right and top to bottom. So and I want sample of 4, and the population is 60 people. So this 60 again tells me that I need to be reading off 2 digits at a time, not 1 digit or not 3 digits. And I'm going to start at 0, 0, 0, 0. And so my first number is 15. And I've chosen to go left to right. So I'm going to go left to right all the way before I get to the next line and the next line if I decide to keep going. So I'm going to go 15. And then my next number is 54. And then my next number is 48, and then my next number is 7. All 4 of these numbers are less than 60, so I can count this as my 4 numbers, and hopefully what I have also done is gone through my roster and numbered everybody from 1 to 60, and students' numbers 15, 54, 48, and 7 are the 4 that I've decided to interview. I don't always want to start here, because if I'm always starting here, then now this table becomes not nearly so random because it's highly selective among these numbers up here. So another way that I could do it was let's do the same sample of 4 from a population of 60, but let's start on line 3, column 1. So line 3 is this one. And the way these columns are numbered is a little bit tricky in that up here it says this is column 00 to 09. And if you count these, here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 columns. So the way that this is numbered is that this column right here, that's 0, 0. This column, the second column, is 0, 1. The third column is 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, 0, 9, 10. 11, 12, 13, 14, 15, 16, 17, 18, 19. And it goes on like that. So if we're looking at line 3, column 0, 1, we're going to start. Actually, before I tell you where we're going to start, I want you to just look at the table and convince yourself where you think we should start before I tell you. And I'm going to start right here. So I want to be reading off 2 digits because 60 is 2 digits long. And I'm starting with column 0, 1, which is the second column in the row. So my first number is 13. My second number is 27. Oh, and I kind of skipped over this, but I've decided instead of going left to right and then top to bottom, I'm going to go top to bottom and then left to right. So I'm going to keep going down until I get to the end of this row. So we're going to go 13, and then 27, and then 14, and then 93. And when I get to my 93, I say, 93, that number's too big. I only have 60 students in my class. So we're going to skip right over 93 and keep going to the next one. And that's 35. One more, just to make sure you've got it. is we're going to start with line 13 and do column 28. So let me go down to line 13. That's this one. And we'll do column 28. This chunk right here is columns 20 to 29, which must mean that the last column here is column 29. So I'm looking at column 28 right here. Just like that, and that's where I want to start. So line 13, column 28, has as its first number 22. Okay, now I've decided to go left to right and then top to bottom, so I'm going to read left to right. My next number is 0, 0, then 99, then 57. I've read off 4 numbers here, and certainly 99 is one that we want to get rid of. We don't need 99. We only have 60 students. With 0, 0, it may or may not be a number that I can include. I'm going to go ahead and cross it off because for me it makes the most sense for me to number my students from 1 to 60 and not 0 to 59. But that might be something that was ambiguous and you'd have to look up what the question had said to decide whether to include number 0, 0. Okay, so now I only have 2, so I have to keep going after 57, and then I have 2, and then I have 17. Just like that. Okay, so one of the questions on your quiz will ask you to use this table in much of the same way that we just did. Okay, so that was SRS. Simple random sampling, and I'm out of order. Nope, I'm not. And that's probably, in a lot of ways, simple random sampling is the gold standard, the thing that you're really making sure that you do. In some ways, it can be impractical, or maybe it doesn't do a great job of making sure that you're adequately sampling some minority populations in your data or something like that. There's a lot of other different types of sampling. So I just want to blow through, it's going to end up being 4 more kinds of sampling to just introduce what they are. So the first one I want to talk about is convenience sampling. And we'll just cover that up for now. This is probably the simplest thing that you could possibly do. So you draw from the population that is close at hand, right? The people, this is, you interview, any example of this is if I'm interested, my population is all of the students at Sage. Well, maybe I set up a table outside of where you get your food at KCC for an hour, and I interview everybody that stops at that table. That would obviously probably be a pretty bad sample from a statistical perspective because that sample that you put is probably not representative of all SAGE students. But it sure was cheap and it sure was convenient. So this is probably the easiest thing that you can do is convenient sampling, but it's the least statistical thing to do. So this is almost never a good way to do it. The next thing that we could do that can oftentimes be just as good as simple as SRS is systematic random sampling. Unfortunately, it would have the same acronym as simple random sampling, but we don't acronym this one, so I guess that's a way to remember it. So this is we choose a random starting point and then we select other members at a fixed sampling interval. So I have a little picture here that I pulled from the internet of one example of a systematic random sample. We start with person number 3, and that person will be randomly chosen. Okay, so I'm going to randomly choose person number 3, and then I'm going to interview every third person. So I'm going to interview person 3, 6, 9, 12, 18, 24, 46, etc. from there on out. So that's systematic random sampling. Another one that starts to get a little bit more complicated is cluster sampling. So this is when We're going to divide the entire population into groups, and we'll call those groups clusters. And then we'll do a random sample of these clusters is selected. And then everyone in the clusters is selected in the sample. So here's a little picture of what a cluster sample would be like. So you had six groups, and each group had 12 items in it. You could use a random number generator or your random number table to randomly pick which two of these six you wanted to look at. And then when you went, you could pick out 1, 2, 3, 4, 5, 6. So maybe you'd use your random number table to pick out a population of 2, a sample of 2 from a population of 6. And that random number generator gave you 1 and 5. So you randomly have chosen groups 1 and 5 to go look at. And now within that group, within that cluster, you look at every single thing within the group. So the example that I wrote on here is if the population is New York State, we'd like information about all of New York State, but that's too hard to do. So let's randomly choose 10 zip codes from within New York State. And we'll go to those zip codes and we'll interview everyone in each one of those 10 zip codes. That would be cluster sampling. And the last one that I want to talk about is stratified random sampling, another, unfortunately, SRS acronym sampling. So in stratified random sampling, we're dividing the population into groups that we're calling strata, and we're randomly selecting some from each of the strata. So using this same analogy where now we have 6 groups, say we don't want, with cluster sampling, right, we randomly picked this group and interviewed everybody within the group. That would be cluster sampling. With stratified random sampling, we're going to make sure that we interview some people within each of these 6 groups, okay? So this way, we're ensuring that we're getting some representation from whatever is in this group and some representation from whatever is in this group, and so far. So the example that I wrote down here is that if now our population is still New York State, but we'd like to make sure that we're sampling adequately from all of the voting age groups. We don't want to just happen to accidentally only get in touch with people who are old enough to still have landlines. So we selectively only interview some of the older people, and that leaves out some of the young people. That might be a reason why we'd like to do stratified random sampling, right? So we have our strata 1 is these younger people. Our strata 2 is these the next age up, and then the next age up, and so on and so forth. We would go to each strata and make sure, and obviously for New York State, there'd be a lot more than 12 people in each strata, but I think the analogy still works here. So we'd go to our youngest group and we'd make sure that we randomly choose a few people in this group to include in our sample. We randomly choose some people in this group to include in our sample, and so on and so forth. So stratified and cluster sampling are by far the hardest ones to get your head around, and we'll spend more time on both of them in class. But I think this visualization here works really well, where in cluster sampling, we're dividing everybody into clusters, and we're randomly choosing which cluster we interview. But then when we go to the cluster, we interview everybody within the cluster. In stratified sampling, we are separating into a bunch of different groups that we call strata, and we are making sure that we are hitting some from each group. In your book, they talk about stratified random sampling with proportional allocation, which would be that you want to kind of make sure that you're sort of getting enough people in your sample that what ends up in your sample is representative and is proportional compared to how many people are actually in each of those groups or strata. So when it comes to quiz time, I'm not going to ask you about the difference between stratified and cluster sampling. So don't worry about that yet. We'll go into detail about that more in class. But I will ask you about the difference between convenience, systematic random sampling, and SRS, the one that uses the random number table. So make sure that you're clear on which of those the differences between those three kinds of sampling. And the question or questions will be very much, an example of something like this, not this one, but something like this one. And it'll say what kind of sampling is it? And you'll have to identify from a list what kind of sampling it is. But it'll only be one of either this one, or SRS. I won't ask about cluster or stratified. And I think that probably covers it. I think I've covered all of the questions that are on the quiz. So there's some information about the syllabus, some information about the types of sampling, and then that one problem about using the table for SRS. And that should do it for this week's lab, or this week's video.